All right, here we go, students. This should be the third video that you're watching at this point, and we left off on example 4. In a survey of adults in the United States, 29%, there's our P, it's a percent, said they have seen a person using a mobile device walk in front of a moving vehicle without looking. You randomly select 100 adults. That's your total number of adults. That's your sample size. There's your N. And ask them whether they have seen a person using a mobile device walk in front of a moving vehicle without looking. What is the probability that more than 30 respond yes? We don't need this till we get to the end of our problem where we draw our bell curve. This comes in at the bell. All right, so here we go. Step 1, NP greater than or equal to 5, NQ greater than or equal to 5. N is 100, P is 0.29, greater than or equal to 5. 100 times 0.29 is 29, greater than or equal to 5. So yes, that side is good. N is a 100. Now I got to find Q. Remember, Q is equal to 1 minus P, and P is 29. So I got to do 1 minus 0.29, and I get 0.71. Greater than or equal to 5. 100 times 0.71 is 71, greater than or equal to 5. Both of these numbers are greater than or equal to 5, so we're good to go. We can do the problem. Mu equals NP. We just found NP right here above to be 29. And sigma equals the square root of NPQ, which is the square root of 100 times 0.29 times 0.71. Again, do not solve that, do not solve that, do not solve that. Leave it just like that. Now we're ready to go to our bell. To get what goes in the bell, you go to the question. What is the probability that more than 30? So we're going to draw a bell, and we're going to put 30 inside. The continuity correction means to add and subtract 0.5. So this is going to be a 29.5. This is going to be a 30.5, and I want the probability of more than 30. It doesn't say 30 or more. It says more than 30. More than 30. Notice that I'm shading all the way out here to infinity. So I want the probability that X is greater than, and I'm starting at 30.5. Now I pick up my calculator. I'm going to go to normal CDF, number 2. Now my lower bound is the 30.5, and my upper bound is the 999,999. The mean, we found the mean right back here. The mean is 29, so I'm going to type in a 29. And the standard deviation is that big square root. Watch how I type this in. Second square root, 100 times 0.29 times 0.71. Close my parentheses, hit paste, hit enter, and you get 0.3. The answer to the problem is 0.3705. If the computer would happen to want you to turn that into a percent, that'd be about 37.05%. I don't know how my math lab's going to want that. All right, next page. Let's do some more. Practice makes permanent. I'm on example 5. A study on aggressive driving found that 47%, there's my P because it's a percent, of drivers say they have yelled at another driver. You randomly select 200 drivers. There's your N, the total number of people in your sample in the United States, and ask them whether they have yelled at another driver. What is the probability that at least 100 drivers say yes, they have yelled at another driver? That's where we get to our bell. We don't need that part till the end of our problem with our bell. Here we go. Mu equals NP. Oh, sorry, wrong formula. I've jumped ahead. Let's try again. NP greater than or equal to 5. NQ greater than or equal to 5. In this case, N is 200. P is 0.47. Greater than or equal to 5. Pick up my calculator. 200 times 0.47 is 94. Is 94 greater than or equal to 5? Yes, it is. Check. Good. Let's keep going. N is 200. Remember, Q is 1 minus P, so that's going to be 1 minus 0.47, making Q 0.53. Greater than or equal to 5. And 200 times 0.53 is 106. 106 is greater than or equal to 5, so check, we can do the problem. Now, mu equals NP, but we just found NP right above here to be 94, so it's done. And sigma equals the square root of NPQ, which is the square root of 200 times 0.47 times 0.53. Again, because we're going to go on, stop there. Do not work that out. I don't want the decimal there. All right, now we're ready for our bell. So the question is, what number goes in our bell? The question that the number that goes in the bell goes to the question of the problem. What is the probability of at least 100 drivers? So inside the curve, we're going to put 100 drivers. If I do my continuity correction, that'd be 99.5 and 100.5, and I want at least 100. If I need at least $100 to buy a something, I need at least $100, I need $100 or more. So I'm going to shade the 100, or I'm going to shade or more, going all the way up to infinity. So this is the probability that X is greater than 99.5. Now I go to my calculator. Here we go. I'm going to go to second dister, number 2. Hold on, let me clear everything out for you. Oh, it's not going to let me. My lower bound in my shading is the 99.5. It's going all the way up to infinity, which is 999,999. In this problem, my mean is 94, so I got to change that to a 94. And my standard deviation, watch again if you're not getting this, second square root. This is 200 times 0.47 times 0.53. Hit paste, hit enter, and you should get 0.2179. So the answer to the problem is 0.2179. Again, I'm not sure how the computer is going to want that, but that's about 21.79%. Example 6. A study on aggressive driving found that 47% of drivers say they have yelled at another driver. You randomly select 200 drivers. Oh, it's the same problem as above, and ask them whether they have yelled at another driver. All right, so this, since these numbers are the same as up here, this part is all the same as down here. The NP, the N is still 200, the P is 0.47, the N is still 200, 1 minus 0.47 is 0.53. This top just can come right down here. I'm just going to be lazy and save myself some time. So the only thing that's going to change on this problem is my bell. So let's draw a bell. What is the probability that at most 80, so 80 is going to go in the bell. This is 79.5. This is 80.5. And I want at most 80 drivers. The most I want is 80. I'll take 80, but it's the most I want. So I want everything less than 80 all the way down to negative infinity. So I'm looking for X less than 80.5. If I turn on my calculator and I go to normal CDF, number 2, now my lower bound to the left is negative infinity, which is negative 999,999. My upper bound is 80.5. My mean from up here above is 94. That stays the same. And my standard deviation is up there from above staying the same. I hit paste, and the answer to this problem is 0.0279. 0.0279. So in this case, with 200 drivers versus, what is the probability of at most 80 compared to at least 100, so 100 or more compared to 80 or less? This is 2.79%. And I'm going to stop there and do the final 4th video for the last page. Give me just a second to get set up.